I'm thinking you remember this formula here. That's the one that we used for constructing a confidence interval for the mean, for large samples, or sigma 1 and sigma 2 are known. So the mean is right here is between, right, is bigger than this and smaller than this. And what are these? These are the sample means plus or minus or plus what the z value, which is the critical value that's determined by our level of confidence, and sigma over the square root of the sample size. Well, now all we're going to do is just expand this formula to account for 2 means and 2 standard deviations. And here it is. Instead of just x bar, we're going to have the difference of the two. So we're going to have, say, x1 bar, the mean of one population, minus the mean of the second population, right? There's the difference of the 2 means. And now, instead of minus just 1 standard deviation and 1 sample size, we're going to have this, minus, all right, still the level of confidence, the critical value, but now it's times this. So instead of 1 square root, we put 2 of them in there. We're going to have sigma 1 squared over n plus, let me extend that, sigma 2 squared, this is n1 and this is n2. That's going to be less than, all right, mu1 minus mu2, less than, now the same thing on the right here, but with a plus sign. So it's going to be quantity x1 bar minus x2 bar plus our critical value times the square root of sigma 1 squared over n1 plus sigma 2 squared over n2. Now that is a big formula, but really all we're doing is just substituting numbers in. And notice this thing right here. You see this? For one sample here, it just has sigma over square root of n. Now what we've got is a big square root, so we're including this sigma under a square root, so we have to square it. So we might be doing this. You know, this thing right here, sigma over square root of n, I could write like this. The square root of sigma squared over n. That makes sense from algebra? Let's construct a 99% confidence interval for the difference of the 2 means, mu1 minus mu2, when we're given this data right here. We're given these statistics. So we have the mean of the first is 15, standard deviation is known to be 3, sample size is 36. The sample mean of the second sample is 14, its standard deviation is known to be 4, and sample size is 40. Now, I've just written the formula, but I didn't stretch it all out, right? I know it's mu1 minus mu2, so I just put the difference of the means plus or minus, that's the error. Remember, this is what we call the maximum error of our estimate. Let's get these numbers in, and we will compute. So we will get x1 bar, which is 15, minus x2 bar, which is 14, plus or minus. Now, we need that critical value. I'm just going to remind us, and then I'll get rid of this. But at 90%, it was 1.64, or some people use 1.65, or some people even cut it in half with 1.645. At 95%, we used that z-score is 1.96. At 98%, it is 2.33. And at 99%, the one that we're looking for is 2.58. So we'll put in here this 2.58. So now we've got the 2.58 times the square root of sigma 1. Now sigma 1 squared, I've got that right here. Sigma 1 is 3, and n1 is 36. So this is going to be, well, let me write a little bit bigger here. 3 squared over 36 plus sigma 2. Now sigma 2 is 4. What a mess. And n2 is 40. So it's going to be 4 squared over 40. Now 15 minus 14 I can do. That's a 1. Plus or minus, I am going to do this part here completely on the calculator. So I'm going to type in 2.58 times, okay, now just press the square root key and type in 3 squared divided by 36. Now when I pressed the squared key, I had to actually use the arrow key to move that 2 out of the exponent. Or you can just press the x squared key down at the bottom left. All right, so I got 3 squared over 36 plus 4 squared over 40. And as you write that, the square root sign continues on like that. Then I'm going to get 1 plus or minus. Now, when I made that computation, press enter, I got 2.08. I'll round off. 2.08. So here's what we're looking at. I'll do it at the top here. We get 1 minus 2.08. That is less than mu1 minus mu2, which is less than 1 plus 2.08. And when we actually make these computations, 1 minus 2.08 is negative 1.08. That is less than mu1 minus mu2, which is less than 1 plus 2.08 is 3.08. And there is our 99% confidence interval for the difference of those two means. And so to interpret it, it says the probability is 99% that this interval right here, contains the actual difference between the two means. Let's do this by calculator. So press the stat key. Then when you hit the stat key, you go over to test, right? So right arrow over to tests. Select tests. And then you're gonna scroll down to, now I'm doing this too, so I'm sure I get it right here for us. There is number 9 to 9, which is two sample z-test is what it says. A z-interval, right? We want an interval, not a test. All right, so stat, over to test, scroll down to number 9, and select that one. So press enter. All right, so you're going to press enter. Now, here's what comes up. You know, you want data or stats. Well, we're going to put in stats, so select stats. We're not putting in data now, we'll just select stats. Then go down to sigma. All right, so here's what you see. Sigma 1. All right, so scroll down, sigma 1, put in a 3. Press arrow down or enter. And then sigma 2, you're going to put in a 4. And then it's asking for x1 bar. So for x1 bar, you're going to put in 15. That was our first mean. Then it's asking for x2 bar. Now x2 bar, you're going to put in, no, it's not asking for x2 bar. What's it asking for? You want x1 bar, and then it wants n1. Okay, I got it. n1. And n1 was 36. Now it wants x2 bar. All right, so x2 bar, that's the 14. All right, so you put in the 14, and then it wants n2. And n2 was 40. All right, so you get that 40 in there. And then it wants the C level. What level of confidence do we want? Ours is, we ran ours at 99%. All right, so you just have to type in 99, or if you like, 0.99. Then press enter, or go to calculate, right? Then you go to calculate, enter, and everything happens magically for us. And here's what I'm getting, all right? I'm getting parentheses. This is the lower limit, negative 1.077, negative 1.077, and then a comma, and then a 3.0767. Now, what did we get? We got this. We got negative 1.08 to 3.08. So you can see that this number here that they're getting is a little bit more accurate because we did some rounding when we used that t-table. So we could report it in parentheses, or if we want to report it like this, negative 1.08. I'm still going to round to 2 decimal places, so I'm still going to round that up, and I'm going to round this up. So negative 1.08 less than mu1 minus mu2 less than 3.08.